Hello, dear student. How are you? I hope you all will be fine. I am also fine. Thank you. Welcome to your channel, that is AZ Science Group. Okay, today I bring a new lecture number 17 of lecture number 17 of Boron Family. And today lecture, in previous lecture, I explained you the general methods of preparation of boranes. But in today lecture, I will be teach you some physical and chemical properties of the boranes. General physical and chemical properties of the borane. Today I will be explain you general properties of borane. And today lecture number 17, properties of boranes. Yeah. Today we will be discuss with very detailed the general properties of the borane. So let's start the topic. General properties of borane. The general property of boranes are: number first, borane, the physical properties of the borane, physical state of the borane. Mostly boranes are volatile in nature. Boranes are volatile gases. Mostly boranes are volatile gases, but may be liquids. Yeah, there is some also large amounts of boranes are also present in liquid and are solids. Means they may be volatile gases, liquid or solids. The another properties is the melting and boiling points. Melting and boiling points of borane. Melting and boiling points. The melting and boiling points of boranes in centigrade are B2H4H10. That is one borane that have minus 120 degree centigrade. That is the melting point of the B2H10, while the boiling point of that compound is 18 degree centigrade. Similarly, for the B5H9, it have 46.6 degree melting point, while 48 degree its boiling point. Similarly, for B5H11, it have minus 62.3 degree melting point, while boiling point is 108 degree. Similarly, for B6H12, it have minus 82.3 degree melting point, while 80 to 90 it is its boiling point. So these are the some compounds of some boranes that have the melting and boiling point in degree centigrade. The another property is the decomposition. What about the decomposition of the borane? So decomposition of boranes. When boranes heated, these compounds they can be decomposed into different boranes. When they are heated, they decompose into different boranes. Decomposed. For example, first of all, the nature of boranes obtained depend on the temperature. The nature of boranes that can be obtained from the another borane that can be obtained on the heating, on the temperature, at which temperature they become heating. So that's why different boranes can be obtained at different temperature from the different boranes. So it means that the boranes can be obtained that depend upon the nature of borane depends upon the temperature. So at any specific temperature, only the specific borane will be produced. The specific borane will be synthesized. As in previous lecture I explained you with very details, at different temperature, same borane produce different boranes at different temperature. Different boranes can be synthesized from the single borane at different temperature. So it means that the nature of the borane depend on the temperature at which decomposition take place is shown in as I explained you previously in previous lectures. I hope it will be cleared. You can also see this lecture. I put their links in description box. You can get from their lecture number 16. In lecture number 16 I explained you at very detail. Today is lecture number 17. So come to the next point. That is next physical property is the hydrolysis. This is not physical property, this is the chemical property. Hydrolysis. Yeah, hydrolysis. These are hydrolyzed by water. These are hydrolyzed by water and aqueous alkalis. These can be hydrolyzed. These are hydrolyzed by water and alkali and aqueous alkali, yeah, and aqueous alkali. The pen is not properly working. Let's change my pen. So these come to the points. Hydrolysis, these are hydrolyzed by water, means borane can be hydrolyzed by water and aqueous alkali but the rate of the their hydrolysis it will be vary from one borane to another. The rate of their hydrolysis it will be varies from one borane to another, one borane to another borane. But in all the cases hydrogen will be evolved. For example, at B4H10 when they are treated with 12H2O, in case of hydrolysis they will produce 4H3BO3 plus 11H2. I explained you here that the rate of their hydrolysis vary from one borane to another. So in another case, for example, the same borane, that is B4H10, when they are treated with potassium hydroxides, they plus water, in the presence of water, they produce 4KBO2 plus 11H2. H2 will be evolved to the atmosphere. Similarly, for another two compounds, that is take the correct position of the camera. Yeah. Similarly, for B6H12, in two cases, when first we treated with water, it will produce 6H3BO3 plus 15H2. Similarly, for this borane, when they are treated with B6H12, when they are treated with potassium hydroxides, they produce what they produce now? They will produce 6KBO2 plus 15H2. So it means the hydrolysis, it can be hydrolyzed, borane can be hydrolyzed by water and aqueous alkalis, that is by water, that is by aqueous alkali. KOH, that is potassium is alkali metal, so that's why we will say that alkali aqueous. In the presence of potassium hydroxide, in the presence of water, that will call be alkali aqueous. So that's why borane can be reacted, can be hydrolyzed by water or aqueous alkali, but the rate of their hydrolysis vary from one borane to another. Yeah, here in this case, this is B4H10 situation, while for another borane B6H12, here is the rate the rate of the reaction will be 1, while in case of B4H10 the rate should be different from the case that I explained you here, that is the one borane, that is the second borane. So these borane will have different rates and different reactions. And same reaction it will have different, means when B4H10 they reacted with aqueous solution, they will produce the compound, they will produce the products, but the rate of this reaction will be different. When the another borane treated with the same water, they will have different rates, so means the rate will be different from one borane to another. So come to the next point. Now I am cleaning the board to proceed the topic. You can take screenshot from here. Also you can rewind the video. Thank you. Physical properties of the borane. The another property of borane is the pen is not working. Why they are not working? Sorry. Yeah, the another property is the action of O2 towards borane. Action of O2 or air towards borane. What will be the behavior of borane in this case? All the boranes are hydrolyzed. All the boranes are easily oxidized by O2, giving dark colored products of determined composition. In this case, a mixture of gaseous borane with air is highly explosive in the presence of the traces of the moisture. All the boranes are easily oxidized by O2 and give dark colored products of determined composition. A mixture of the gaseous borane with air is highly explosive in the presence of traces of moisture. These are the another properties. Come to the next property, that is the formation of addition. Formation of addition compounds means where adducts are formed. Formation of addition compounds. Since in all boranes are electron deficient compounds, from these compounds, from the addition compounds, various adducts or various donor molecules can take, so various adduct will be produced. These are actually electron deficient compounds. All the boranes are electron deficient compounds. So that's why different varieties of donor atom of donor atom can be attack on donor atom or molecule can be attack on this electron deficient compounds. So that's why they will be produced, they can be produced different adducts. How can you define adducts? Adducts, it is the additional compounds that may be any allies, that may be any different compounds of when two different molecules are two single molecules, when they are combined together and form a one combined product. These two molecules are in same product, are in same compound. The two molecules that makes one compound, so that make one molecule, single molecule or single compound, that will be called adducts, additional products. So that will be called adducts. Adducts mean additional products, addition compounds. Adducts mean addition compound. So that's why they can be produced electron deficient compounds. Come to the next point. That is not third point, that was 7 points, because that is 6, that is 7. So come to the next point, that is 8. Action of NH3. What about NH3 when they are treated with boranes? When they bring to word borane, all the boranes react with NH3 to produce all the boranes. They can react with NH3 and they will produce various products. They can produce various products, but these products will be depending upon the experimental condition. It will be depend upon the experimental condition. Similarly, properties of tetraborane. Tetraborane, that is also one borane, which is tetraboran 10, means according to nomenclature, tetraboran which have 4 boron. Tetra means 4, borane means boron, and 10 means 10 hydrogen. So before a 10, that will become formula. It is come to this point. These are the general properties of borane that I explained to you, but now I will be explaining you the general properties of the tetraboranes. So the first property, it is colorless. It is colorless gas. It is always a poisonous gas. It is poisonous gas with distinguished odor. It have very distinguished odors. Distinguishing odor. These can be readily condensed to a colorless liquid with melting points up to 120 degrees centigrade, minus 120 degrees centigrade. That is the melting points. This can be condensed up to colorless. This can be condensed up to liquid when the temperature decreases up to minus 120 degrees centigrade, below the minus 120 degrees centigrade. That is which is the melting points of the tetraboran 10, while the boiling point of the tetraboran 10 is 18 degrees centigrade. See, it is also non-flammable in dry air. It is also non-flammable. means it cannot capture the fire. It is non-flammable in dry air. At room temperature it cannot be get any it cannot be catch fire at room temperature. Yeah, a mixture of gas with air, a mixture of these gases, the mixture of tetraborane, the mixture of gas with very high explosive in the presence of traces of moisture means it can be very dangerous when any moisture are present. When any moisture are present, when any water molecule are present, means it is very this is also means it have very highly reactive towards water, highly reactive towards water. You can also say that it has hygroscopic in nature. Hygroscopic means that can absorb water from the atmosphere. Hygroscopic in nature, but they are very explosive when the mixture is present, when they are placed in the open atmosphere where the moisture is present, where the water molecule is present in the atmosphere. So they will be very explosive to this. They can be very dangerous. The result will be very dangerous for the same position. Also, the another property of tetraborane is, you can rewind the video to take screenshot or to write on your assignments, your notes book. Okay, the another property of the tetraborane is it is soluble in dry benzene. It is soluble in dry benzene. It is soluble in dry benzene, but slightly in cold water. Slightly soluble in cold water, but highly soluble in dry benzenes. These are also the one properties of the tetraborane. I hope it will be cleared. Still, if you have any confusion, if you have any question, you can ask me in comment section anytime, everywhere. Where are you? It doesn't depend that you should be in school, in college, in home. Where are you? You can ask me anytime in my personal WhatsApp, also in my personal Gmail. Also, you can also take any message. You can take my personal WhatsApp or Gmail from the description box. I drop there. Okay, the next property is decomposition of the tetraborane. Decomposition, it is stable in the absence of air. It is very stable in the absence of air. In absence of air and moisture. It is stable in absence of air and moisture. It decomposes at ordinary temperature. At ordinary temperature, it decomposes. At ordinary temperature, yeah, but at this temperature it will be give hydrogen H2 and also produced a lower borane. These are the higher borane. Before 18 tetraborane 10 are higher borane. At lower temperature it can be decomposed. At ordinary temperature it can be decomposed and to lower borane, as well as H2 will be evolved, giving H2 will be synthesized, produced. Similarly, HCl action of hydrochloric acid. HCl is also can attack. HCl can also treat with this compounds, and in the product H2 will be liberated. H2 is be liberated. For example, B4H10 plus when HCl are treated, it will produce B4H9 Cl plus H2 will be produced, synthesized. So means HCl can also be treated, HCl can also be attacked on this compounds, on tetraboranes. The another property is reaction with CO, carbon monoxide. What will be reacts? B4H10, that is tetraborane 10, B4H10, it can also react with carbon monoxide at 120 degrees centigrade temperature in hot cold water, in hot cold flow water, not flow water, flow reactor, in hot cold flow reactor. and if in this reaction the product will be at synthesized it will be synthesized, it will be give us carbonyl adduct. It will be always give us carbonyl adduct when this borane treated with the carbon monoxide at 120 degree centigrade temperature in hot cold flow reactor. It will be give us carbonyl adduct. So carbonyl adduct is the B4H8CO, that is one carbonyl adduct, plus H2 will be also produced. For example, the reaction become B4H10 when carbon monoxides are treated, it will produce B4H8CO plus H2. These are the adducts. This is also adducts, also called adduct, because it is the combination of two compounds that produce one compound. It is also additional compounds, one another compound are added, so that is why this will be called adducts. This is also adduct because one another compound, addition of another compound is occurred, so that's why these are adducts. These are the general characteristics. Also hydrolysis of tetraborane. It is slowly hydrolyzed by H2. Tetraborane hydrolysis, it is slowly hydrolyzed by H2O and reacts with NaH, slowly react with by water. Also it can be react with the aqueous alkali. Aqueous alkali means when the solution of alkaline earth metals in water are present, so this is called aqueous alkali. It can be produced it will be produced H2 plus another hydrolysis, another borane can be produced, that is can be lower borane. Another property is action of NaH and NaBH4 towards before H10. Action of NaH and NaBH4. Action of NaH and NaBH4 when they are bring towards H4 H10, that is called tetraboran 10. When they are reacts with the NaH or NaBH4, it will produce one compound that is called Na plus. You can write also that Na into B3H8. This is the ionic compounds, means ion are produced here. So it will be produced this coordination compounds, which is ionic compounds. These are the ionic compounds because ionic are produced. It is also called salt formation. So when with the reaction of NaH and NaBH4, it produce these compounds. Similarly, for B4H10 when they are treated with the B4H10 when they are treated with 2NaBH4, it will also produce 2Na plus B3H8 minus. In all the cases H2 will be liberated. H2 plus H2 will be liberated. But here in B4H10 when they are treated with the NaH, it will also one another compound produced plus B2H6, B3H8 Na. So these are the general properties of the tetraboran 10s. This is also tetraboran 10 is one borane. The another borane you may know that is called pentaboran 9. Penta means that is 4 borans, while this 9 means there are 9 hydrogen, means B4H9. This compound is called pentaboran according to the nomenclature of the boranes. So what about this borane? What is the also properties of this boranes? How can this borane can be produced, synthesized? What is the property of the pentaboran? Okay, come to the points. So yeah, come to this point, so that is called properties of what about the pentaborane. That is also one borane, pentaborane. Sorry for changing the markers. This is called pentaborane. Pentaborane 6, pentaborane 9. So okay, come to the next point. So next properties of borane that have what about the pentaborane 9. Pentaborane 9 property, pentaborane 9, penta means where is 5 according to nomenclature. Penta means where is 5, pentaboran means 5 boron, boron that has 5 in nature. 5 means 5 boron, while this 9 means 9 hydrogen. So B5H9, that is pentaborane. That is pentaborane. This is pentaborane. So some of the reaction of pentaborane is this I am writing here below. Some of the characteristics, some of the properties of this pentaborane is B5H9 when they are treated, when they are reacted with ethane, when they are reacted with the ethene in the presence of AlCl3, it is the electron deficient compound. It can be oxidized, it can be reduced boron. AlCl3 itself, they are oxidizing agents. So in the presence of AlCl3, when ethene or ethylene are treated with the B5H9 pentaborane 9, they will produce B5H8C2H5. Yeah, similarly the another property, when the same compound B5H9 they are treated with LiH, this is also the hydrides of alkali, the lithium hydrides. When they are treated with when they are treated with the pentaborane 9 in the presence of diethyl ether, what will they produce? They will produce Li2B5H11. Similarly, B5H9 when they are treated with 2NaHg, what they will produce? They will be produced in the presence of they will be produced Na2B5H9 in the presence of ether, plus when the vacuum are produced in the presence of vacuum through vacuum distillation, through vacuum pump, when produce vacuum, it can be converted into again B5H9. Similarly, for B5H9 when they are treated with lithium elements in the presence of liquid ammonia, NH3, it will produce Li2B5H9. So these are the general about pentaborane 9, general reaction of pentaborane 9. But what about pentaborane, properties of pentaborane 11? What this mean? Penta means B5, 5 boron. This 11 means 11 hydrogen. B5H11, they are called, according to nomenclature, they will be called B5H11, they will be called pentaborane 11. So their property, their general characteristic is in the presence of Lewis acid, in the presence of Lewis bases like ether, in the presence of Lewis base like ether, are amines, etc. In the presence of ether like amines, etc., B5H11, it will be give us B4H10 and B2H4 B2H6, they will be produces. For example, 2B5H11 in the presence of Lewis base, it will produce B6H10 plus 2B2H2 H6. These are the one reaction of the pentaborane 11. Also B5H11 when they are treated with carbon monoxides, when they are treated with the carbon monoxides in hot cold flow reactor, it will give us B4H8CO carbon monoxide plus BH3CO. It will be give us these compounds. Also it can give us another compounds when they are heated with H2. What they give us when they are heated with H2 at 100 degrees centigrade temperature, means when B5H11 are treated with H2 in 100 degrees centigrade temperature, it will be produced B4H10. It will be produced B4H10. Yeah. So these are the general characteristics, general properties of the pentaborane 11, pentaborane 9. So what about the decaborane 14th? That is one another compounds. This is called decaborane 14th. You can rewind the video, you can take screenshot from this video, or you can also copy. You can pause the video and note it on your notebook. Let's discuss some general properties of the decaborane. Properties of decaborane 14th. Decaborane 14, according to nomenclature, it means that where deca means 10, so it should be 10 boron, while hydrogen number will be denoted from this number, which will 14. So B1014. What about B1014? The some reaction of B1014, these hydrides are when they are treated with sodium hydrides. When B10H14 when they are treated with sodium hydride, it will produce, in the presence of C2H52O, in the presence of diethyl ether, it will be produced in a B10H13 dot C2H52O plus H2 will be evolved. So they can be produced, these compounds, this adducts. This is also adducts. It can be react with another compounds B10H14 in the presence of sodium metal, also in the presence of liquid ammonia, it will be give us Na plus 2, it will be give us Na2 N2 B10H14 minus 2, it will be give us these compounds. Similarly, in the presence of, when they are treated with the compounds like B10H14, when they are treated with the compounds, this is L compounds, where L can be represented, where L means L is equal to CH3CN R3N. These are the electron donating groups. R3P. When the presence of these groups, when they are treated with the B10H14, or you can say that decaborane 14, when they are treated with these compounds, it will be produced B10H12L2 plus hydrogen will be evolved to the atmosphere. Similarly, when they are treated with B10H14, when they are treated with the CH3Mg plus CH3Mg, it will produce, when they are heated, it will produce the B10H13 Mgi plus CH4. It will produce these compounds. So these all are about the general properties of the boranes. I hope it will be clear. And also I explained you the one another property, that pentaborane 9, 10, pentaborane 11, decaborane 14. I also explained the tetraborane 10, that is called before 18. So I also explained you general properties of general characteristic of the boranes. But in tomorrow lecture, in next lecture, I will be explaining, we will be discussing the one another topic of borane, that is called diboranes, with very detailed, that is very large topics, very detailed topics. I will be explaining you with very details the diboranes, that is also called B2H6. Then in the next lecture, our target will be to complete elaborate diboranes. After that, we will be go to the next points. Next lecture proceeds, and we will be explain the diborane in it can be explained in either in one lecture or in two lectures, but we will be completely finished diboranes in coming lectures. Okay, thank you very much. Still, if you have any confusion in today's lecture, if you have any question, you can ask me in comment section, as well as you can ask me in my personal WhatsApp or Gmail that I put in description box. You can get from there. I hope it will be cleared to you. Okay, thank you very much, and also please subscribe my channel. It makes me feel happy that my students are supporting me. Okay, thank you very much. Very best of luck.